Good morning, students. Today is the first lecture of Design of Machine Element 2. In the last semester, we have seen Design of Machine Element 1. In the Design of Machine Element 1, basically we have seen design of a shaft, then design of a screw jack, threaded and welded joints, as well as design of a spring. In this semester, mainly we will focus on a design of gears. There are various types of gears which are used in automobiles as well as in day-to-day applications. These gears are classified according to their tooth position and shaft arrangement. These gears are spur gears, helical gears, bevel gears, and worm and worm gears. In a case of spur gears are used mainly when shaft arrangement is parallel to each other. Helical gears are also used in a case of shaft arrangement parallel to each other. But teeth are inclined to axis of the shaft. In a case of bevel gear, shafts are at 90 degrees to each other, and in a case of worm and worm wheel, shafts are non-parallel, non-intersecting. Today we'll see introduction to spur gear. So here you can see these gears teeth are parallel to shaft axis. Now we'll see what is gear. So according to definition, gears are defined as toothed wheels or multi-lobed cams which transmit power and motion from one shaft to another by means of successive engagement of teeth. If we are considering a friction disc which are sliding over each other, this concept you have learned in theory of machine 2. So in that case, if two discs are rotating over each other or two friction discs are rotating over each other, they will transmit motion as well as power from one disc to another disc. In this case, when we consider a gear transmission, power transmission with the help of gears are mounted on the shaft with the help of key weight. So when power transmission will take place, power will be transmitted from driving shaft to keyway or keys, and from keys to driving gear. Driving gear will mesh with the driven gear, from driven gear to keys, and keys to driven shaft, and driven shaft to required application. So this is the transmission of a power from driving gear to driven gear to required application. There are various types of drives available like belt and rope drive, chain drive, and gear drive. But mainly belt rope drive or chain drives are utilized when center to center distance is very large. When distance is small, then gear drives are utilized. Gear drives offer various advantages compared with chain and belt drives. It is a positive drive and velocity ratio remains constant. Then center distance between the shaft is relatively small, which results in compact construction. Then it can transmit very large power, which is beyond the range of belt or chain drives. It can transmit motion at very low velocity, which is not possible with the help of belt drives. We consider efficiency of gear drive is very high as compared to belt and rope drive as well as chain drive. Even if its efficiency is 99% in case of spur gears. A provision can be made in the gearbox in gear shifting, thus changing the velocity ratio over a wide range. As there are advantages, there are disadvantages also. So disadvantages offered by the gear drive, they are costly because their manufacturing is complex as compared to belt, rope and chain drive, as well as their maintenance is also high. They should be having precise dimension as well as alignment. Gear manufacturing also, after gear manufacturing, they also required some heat treatments. So again, cost will increase. According to application, they can be made up of cast iron, they can be made up of steel or alloy steel. So according to material, their cost will be increased. Then they also require lubrication. Now we'll see spur gears. If you can see over here, this is the small gear, and this smaller gear is known as a pinion and larger gear is known as a gear. And if you can see this portion, whole position, this is the position for the shaft, and you can see this is a parallel to each other. So spur gears are used to transmit power and rotary motion between parallel shafts. If teeth of the gear wheels are parallel to the axis of the wheel, the gears are called spur gears. It is used when axis of the driving and driven shafts are parallel and coplanar. Law of gearing. Already you have learned this law of gearing in theory of machine 2. The law of gearing is stated as shape of the teeth of the gear must be such that the common normal at the point of a contact between two teeth must always pass through a fixed point on the line of a centers. Here you can see, here point of contact is a C point. O1 is the center of one of the gear and O2 is the center of the another gear, and C is the point of a contact, and NN is the common normal which is passing through the point of a contact. Okay, so every gear, when they are in a meshing, they have to obey law of gearing. Now gear nomenclature. In a gear nomenclature, gear ratio, it is the ratio of number of teeth of the wheel gear to that of the pinion is known as a gear ratio. So it is a Z2 by Z1. Most of the time pinion will be the driving gear and gear is the driven gear. So Z1 number of teeth on the pinion, and if Z2 number of teeth on the gear, then gear ratio will be Z2 by Z1 and gear ratio is always greater than 1. Then transmission ratio. It is the ratio of angular speed of the first driving gear of a train of gears to that of the last driven gear is called as the transmission ratio. Then there are two gear tooth profiles. One is a cycloidal gear tooth profile and another one is an involute gear tooth profile. Cycloid, it is a curve generated by a point on a circle which rolls without slipping on a fixed line is known as a cycloid. And involute is a plane or curve generated by a point on a straight line which is rolls without slipping on the fixed circle is known as a involute, or it is always tangent at that position. Then face width. You can see or here face width, the width over the toothed part of a gear measured along a straight line generator of the reference cylinder is known as a face width. Base circle. Base circle, or it is the smallest circle. In an involute cylindrical gear, the base circle of the involute of the tooth profile is known as a base circle. Circular pitch, you can see over here, this is a circular pitch. Circular pitch is the distance on the pitch circle from a point on a tooth to the corresponding point of the adjacent tooth. So it is a point on the distance on the pitch circle from a point on a tooth to the corresponding point on the adjacent tooth. So circular pitch is equal to pi d divided by z. Then diametral pitch, it is defined as the number of teeth of the gear divided by the pitch circle diameter. So circular pitch and diametral pitch both are the different things. So diametral pitch is equal to Z divided by D, where Z is what? Number of teeth on the gear and D is a pitch circle diameter. So circular pitch into diametral pitch is equal to pi. Module. Module is very important term. When we design a gear, we find out a module. And module of meshing gears is always same. It is defined as the pitch circle diameter per unit number of teeth. So M is equal to D divided by Z. D divided by Z. That is a pitch circle diameter divided by number of teeth, or it is inverse of diametral pitch, that is 1 by P. Pressure angle, the angle between the line of action that is a line through the pitch point and tangential to the base circle, and line perpendicular to the line of centers at the pitch point is known as a pressure angle. So according to pressure angle, mainly pressure angle is 14.5 degree or 14 and a half degree, then 20 degree and 20 degree stub involute. So there are three systems according to that, that is a 14 and a half degree involute system, 20 degree involute system and 20 degree stub involute system. Center distance, it is the distance between centers of the two gears in a mesh is known as a center distance, and C is equal to half D1 plus D2, and it is equal to M by 2 Z1 plus Z2, because C is equal to half D1 plus D2, D is M into Z1. You can see over here, M is equal to D by Z, so D is equal to M into Z. So here it is mz1 plus mz2, and module will be a common term. So C is equal to m by 2 z1 plus z2. Then backlash, it is the difference between tooth space and tooth width is known as the backlash. And clearance, the difference between the dedendum of one gear and the addendum of the mating gear is known as a clearance. You can see over here. Here it is a dedendum of the one gear, and addendum of the mating gear will be over here, and the distance between these two circles is known as a clearance. So it is the clearance circle, you can see. Then these are the systems. The involute profile satisfies the fundamental law of gearing at any center distance. All involute gears of a given module and a pressure angle are completely interchangeable. Then all involute gears of a given module and pressure angle can be machined from one single tool, and the basic rack of an involute profile has a straight sides. So here these are three systems, 14 and a half full depth involute. These are its dimensions. Same way 20-degree full depth involute and 20-degree stub tooth involute system. Then proportions of a standard involute teeth. You can see this is the addendum height. This is the pitch circle. Below pitch circle, distance from dedendum circle to pitch circle is a dedendum height, and from top surface to pitch circle is the addendum height. This is the top length. This is the face width. Above pitch circle, there is a face and there is a flank portion. So for these three system, pressure angle 14.5, 20 degree and 20 degree stub. Addendum is equal to standard module, or it is equal to one module for 14 and a half and 20 degree full depth system, and for a 20 degree stub it is a 0.8 m. Dedendum is 1.157 m, 1.25 m and m. Clearance, then working depth, hole depth and tooth thickness is given. Mainly we will focus, most of the times your problems will be based on 20-degree full depth involute system, and when we consider design of the gear, we find out each and every dimension in terms of a module. So here also you can see everything is addendum, dedendum, clearance, working depth, hole depth, tooth thickness, everything is in terms of a module. Advantages of a spur gear. Spur gears having high power transmission efficiency, they are compact and easy to install, offer constant velocity ratio, and they are positive drives, and they can transmit a large amount of power even up to 50,000 kilowatt. Then disadvantages, they are costly as compared to belt drive, they have a limited center distance, and spur gears produce a lot of noise when operating at a high speeds. Application of a spur gear, spur gears have various applications. Some of them are metal cutting machines, marine engineering, fuel pumps, mechanical clocks and watches, gear motors and gear pumps, automobile gearboxes, rolling mills and steel mills. So in most of the applications, we can use spur gears. Okay. So this is regarding introduction to spur gear. From next lecture, we'll see force analysis as well as design of a spur gear.